Hello everyone, welcome to today's lecture. In our today's lecture we are going to learn about algorithm for frequent pattern finding, and that algorithm is a Apriori algorithm. So the Apriori algorithm assumes that any subset of a frequent item set must be a frequent. So that is the basic concept. Suppose one bought wine, chips and bread together. It means that wine, chips and breads are the frequent item set, and wine and bread is also a frequent item set. Chips and bread is also a frequent item set, and why? So this is how the frequent items that is considered in the Apriori algorithm. How does the Apriori algorithm works? So the key concept in the Apriori algorithm is that it assumes all subsets of frequent item set must be a frequent. Also, it also consider for any infrequent item set, all its superset must be a infrequent. If it is a frequent, then subset is also frequent, and if it is a infrequent, then superset of that item is also infrequent. So let us try to understand the working of Apriori algorithm with the help of very formal business scenario, a market basket analysis. So suppose this is a transactional database. So here is a database consisting of 6 transactions in a hour. Each transaction is a combination of zeros and ones, where 0 represents the absence of an item and 1 represents the presence of its item. So here there are 6 transactions of wine, chips, bread and milk. So here in the first transaction, wine, chips, bread and milk is purchased. In second transaction, wine, bread and milk is purchased. In third transaction, only bread and milk is purchased. In fourth transaction, only a chips is purchased. In fifth transaction, all the items is purchased. And in sixth transaction, wine, chips and milk is purchased. So based on this data set, we can say that when people bought wine and chips, then it also bought a bread together. Yes, so this is a frequent item set of wine, chips and bread. So we can also say that if customer buy wines and chips, then it is also bought a bread. If it bought a bread and chips, then it is also bought a wine. So this is how the Apriori algorithm is used for finding the frequent item set. So we can find a multiple rules from this scenario. For example, in a transaction of wine, chips and bread, if wine and chips are brought together, then customer is also buy bread. So this is association rule, like wine and chips implies bread. So in order to select the interesting rules of multiple possible rule from this small business scenario using the following measures. Yes, suppose we have created the frequent item set, but how we can evaluate that algorithm? How we can evaluate that rules? So evaluation is done via these two measures. First is the support and second is the confidence. So support of item X is nothing but the ratio of number of transactions in which the item X appears to the total numbers of transactions. Here we will calculate the support of wine. So in the transaction history, wine is occurred 1, 2, 3, 4 times, and the total number of transactions is 6. So 4 divided by 6 is become the support. Next is the confidence. Support doesn't consider the outcomes. Yes, here, and the confidence consider the outcomes also. Suppose here wines and chips implies bread, so confidence also covered the bread to calculate the measure of association rule. So a confidence X implies Y signifies the likelihood of the item Y being purchased when X is purchased. So this method take into the accounts of the popularity of the item. So the confidence is supports of wine, chips and bread together divided by supports of wine and chips. Now let's consider in which transaction wine, chips and bread is bought together. So transaction number 1 and transaction number 5. So 2 times this items is purchased together. So 2 divided by 6 divide supports of wine and chips. So wine and chips occur together 1, 2 and 3 times. So 3 divided by 6. So this is how confidence is calculated. So this is are the main measure that is too important while we are calculating for a priori algorithm. So let's understand it with the example. Okay, so this is the transaction history that is given in the question. So here the 4 transaction is given. The transaction ID is 100, 200, 300 and 400, and this is the item set that is purchased in each transaction. So this is given in the question. In the question, with this information, 2 other information is also given. First is a minimum support and second is a minimum confidence. Yes, now you know that what is a support and confidence. So the first thing you need to do is convert that support percentage into the support count. So for that you need to convert into 50 divided by 100 into number of transaction. Here the number of transaction is 1, 2, 3 and 4. So the number of transaction is 4. So the answer is 2. Yes, so here support count is 2. So that is the first thing we need to calculate it from the support percentage. Yes, we'll take confidence as it is a 70%. Yes, so this is first thing we need to do while solving this example. Now the first step for the a priori algorithm is scan the database for the count of each candidate. Like we'll consider only the non-repeated items. So here the item set contains 1, 3, 4, 2, 3, 5, 1, 2, 3, 5 and 2, 5. Yeah, so we'll consider each item as a one time. So we'll consider first 1, 2, 3, 4 and 5. So there are 5 item sets there is in the transaction history. Now the second thing we need to do is find the support. We'll find the support of each and every item set from this data set. So support means occurrence of each item set. So 1 occurred 1, 2 times. So the support is 2. Now 2 occurred as 2 and 2 and 2. So support of 2 is 3. 3 repeated as 3, 1, 2 and 3. So support is 3. Next 4 repeated 1 and 1 time. 5 repeated 1, 2 and 3 times. So this is how the support is calculated. Now this item set, this whole table is called as a candidate table and it is counted and it is called as C1 table. Now from C1 we'll calculate the L1. Okay, now compare the candidate support count with minimum support. Now we know that minimum support is 50% and the minimum count is support count is 2. So we'll take each item set here. So here we'll only consider those items whose support count is greater than 2. Here minimum support is 2, so we cannot take any value whose support is less than 2. So here the only item whose support is less than 2 is a 4. Yes, so we'll calculate, we'll discard that item from this table and we'll consider only 1, 2, 3 and 5 item set in the further calculation. So the item is 1, 2, 3 and 5. Yes, with their support. The support of 1, 2, 3 is 2, 3, 3, 2, 3, 3 and support of 5 is also 3. So this is how the second step is calculated. From first table we'll compare the support value with the minimum support count and discard those items whose support count is less than that minimum support count. Now the next step is generate C2 from L1. Now we have this item set. Now we'll create a new item set in group. So this is created as something like that, like 1, 2, 1, 3, 1, 5, 2, 3, 2, 5 and 3, 5. So this is we'll calculate from this item set: 1 with 2, 1 with 3, 1 with 5, 2 with 3, 2 with 5, 3 with 5. We'll not consider 5 with 1 because this is already here 1 and 5. So repeated value can't be considered. So this is how we can generate the C2 from L1 with their support. Now we have to count the support of 1 and 2, 1 and 3, 1 and 5 from the given table. So the support of 1 and 2 means how many times 1 and 2 is repeated in this given data set. So 1 and 2 is repeated only one time. So we'll write 1 support here. Now 1 and 3. So 1 and 3 is repeated 1 and 3 and 1 and 3 two times. So the support of 1 and 3 is 2. Now 1 and 5. So the support of 1 and 5 is 1, 5 is only 1. So we'll write 1 here. Now next is 2 and 3. So 2 and 3 is repeated 2 and 3 and 2 and 3 two times. So we'll write support as 2. Now next is 2 and 5. So 2 and 5, 2 and 5 and 2 and 5 repeated 3 times. So support is 2 and 3. And next is 3 and 5. So 3 and 5 is repeated 2 times. 3 and 5 and 3 and 5. We'll write here 2. Now this is a table L2. So that is created from L1. Now the next step, that is all I already done here, that scan the database for count of each candidate in C2 and find the support. So this is how the candidate C2 is created. Now from C2 we'll again create L2. As we are created C1 and then from C1 we'll calculate L1. Now we'll calculate C2. So from C2 we'll go to the L2. So for L2 we'll compare the C2 and C2 support with minimum support and discard the item set with the lower support. So we know that the lower support with lower item set is 1 and 1. We know this minimum support count is 2 and the item with less than 2 support is discarded. So this 2, 1 and 5 and 1 and 2 is discarded. So the remaining item is 1 and 3, 2 and 3, 1 and 3, 2 and 3, 2 and 5 and 3 and 5. Yes. So these are the remaining item: 1 and 3, 2 and 3, 2 and 5 and 3 and 5. Now again we have to count the support of each item. So 1 and 3 we know that repeated 2 times. So we'll write support here 2. 2 and 3 is repeated 2 times. So we'll write 2 and 3 here 2. 2 and 5 is repeated 3 times and 3 and 5 repeated 2 times. So this is how the support is also counted. Now from L2 we'll calculate again C3. So for C3 again we have to create a pair. For L1 table we have to create only 2 pairs, 1 and 3. Yes, 2 and 3. Now now in the table L2 2 pair is already there. So we'll create triplets from this item set. So the triplets is considered as 1 and 3, So first we'll consider 1 and 3, and 1 and 3 with this item set. So 1 and 3 and 2 and 3. So 3 is already repeated. So we'll only consider 1, 3, 2. So we 1, 3 and 2. Next item is 1, 3, 2, 5. Yes, so none of the item is repeated. So we'll write 1, 3, 2, 5. 1, 3, 2, 5. Next is 1, 3. Next is 1, 3 with 3, 5. So 1, 3 is already repeated. We'll consider only at one time. So 1, 3 and 5. So here 1, 3 and 5. Again 2 with the 2, 5. Sorry, 2, 3 with the 2, 5. So 2, 3. 2 is repeated. So 2, 3, 5. So we'll write 2, 3, 5. And 2, 3, 5 is already generated, so we will not create it again. Next is 2, 5. So 2, 5 with 3, 5. So 2, 5, 3. The 2, 5, 3 is already there, so we will not create it again. So this is how the item set is created from 2 to 3. So now we'll write each item set here. 1, 3, 2. 1, 3, 2, 5. 1, 3, 5. And 2, 3, 5. Yes. Now we'll calculate the support of each item. So 1, 3, 2. So how many times this 1, 3, 2 item is occurred together? So in the data set 1, 3, 2. So 1, 3, 2 is only occurred one time. So I'll write support as 1, 1, 3, 2, 5. So 1, 3, 2, 5 is occurred one time. So we'll write 1 here. Now next is 1, 3, 5. So 1, 3, 5 is only occurred one time. So I'll write support as 1 and 2, 3, 5. So 2, 3, 5 is 2, 3, 5 and 2, 3, 5. So these occurred repeated 2 times. So we'll write support 2. Now same, this is a C3. Yes, from C3 we'll calculate L3. For that we'll consider the minimum support count and the item set whose support count is less than that minimum support count, which is a 2. So that is discarded. So 1, 3, 2 support count is 1, 1, 3, 2, 5 and 1, 3, 5, whose all three items which has support count less than 2. So that item is discarded. So L3 contain only this one item set, which is a 2, 3, 5. So it contains only one item set, 2, 3, 5, and support is 2. Yes. So this is our final frequent item set. So from Apriori algorithm will reaches to the item set which is a frequent. Yes. So now our work is from this frequent item set will create the association rule. So generate the association rule from L3 with their support and confidence. Yes. Now we all know this association rule is a if then rule. So this is created something like that. 2 and 3 implies 5. So this is a first rule, that 2 and 3 implies 5. Next rule is 3 and 5. 3 and 5 implies 2. Third one is 2 and 5 implies 3. So these are 3 basic rules. Now we'll invert this rule and again create 3 more rules, like 5 implies 2 and 3. This is a 5 implies 2 and 3. 2 implies 3 and 5. And 3 implies 2 and 5. Yes. So this is how our association rule is generated. Now we need to find the support. Now the support of frequent item set is 2. So the support of each of the association rule is also 2. So we have to write the support of each rule as 2. Yes, now support is written as 2 for each rule. Now we have to find the confidence, and the equation for the confidence is, we'll already learn in our previous slides that support is if A and B imply C. So the support, so the confidence is equals to support of A and B and C divided by support of A and B. So this is the equation for finding the confidence. So now our rule is 2 and 3 implies 5. So support of 2, 3, 5. So we have to write support of 2, 3 and 5 divided by support of 2 and 3. Now we all know that support of 2, 3, 5 is 2. So we'll write 2 divided by support of 2 and 3. So support of 2 and 3 is 2. So I'll write 2 here. So it confidence become 1. Now for 3 and 5, support of 2, 3, 5, which is already a 2, and support of 3 and 5. So support of 3 and 5, it is already 2. So I'll write 2 here and is equals to 1. Now support of 2, 3, 5, which is already 2, divided by support of 2 and 5. The support of 2 and 5 is equals to 3. So we'll write 3 here, which becomes 0.66. Now support of 5, 2, 3. 2, 3, 5. So support of 2, 3, 5 is equals to 2 divided by support of 5. Support of 5 will calculate from here, which is a 3. So I'll write 3 here, which is again 0.66. Now support of also 2, 3, 5 divided by support of 2. So 2, 3, 5 support is 2 divided by support of 2, which becomes 3. So I'll write 3 here, which is again 0.66. Now support of 2, 3, 5, which is already 2 divided by support of 3, and the support of 3 is 3. So I'll write 3 here, so it is again 0.66. And the last step is convert that confidence into the percentage, and for that we'll only multiply it by 100. So confidence is 100%, it is 100%, it is 66%, it's around 66%, 66% and 66%. Okay, so this is how our confidence is calculated. Now the minimum confidence is already given in the question, which is 70%. So same as we have to compare the confidence of our calculated confidence with this minimum confidence and discard those items whose support is less than 70%. Yes, less than minimum support. So now we know that 66% is less than the 70%. So we'll discard all that rules which has 66% support. So, and these are the two rules which has a 100% support, 100% confidence. So we'll continue with these two rules. So these two rules are 2 and 3 implies 5, and 3 and 5 implies. So these are our final association rule that is used to find the frequent item sets. So these are the final rules. So that is, this rule is written as the final rules are 2 and 3 implies 5, and 3 and 5 implies 2. So this is how the a priori algorithm is used to find the frequent item sets, and from that frequent item set we will calculate the association rule. So again I will repeat. The question is given something like that with minimum support and confidence. First thing, we have to convert the minimum support into the support count, and for that the minimum support divided by 100 into number of transaction. Here number of transaction is 4, so it is written as 4. So the minimum support is 2. Now we have to select individual items. So 1 2 3 4 5. We'll write the support of each item. So 1 is repeated 2 times, so that is why support is 2. 2 is repeated 3 times, so support is 3. So this is how support of each item is counted. So this is also called C1 candidate set. Now from C1 we'll generate the L2. So for L2 we'll compare the support of each item set with the minimum support and discard those items whose support is less than 2. So we'll discard the 4 and the remaining item set is 1 2 3 5 and with their minimum support. Now we'll again generate the candidate C2 from L1. So we'll create the pair of each item sets. So 1 2 1 3 1 5 2 3 2 5 and 3 5. Repeated item sets is not allowed here, so we'll only write the identical item sets. Now we'll write support of each item set. So 1 3 is repeated in database 1 time, so support is 1. 1 3 repeated 2 times, so support is 2. So this is how support of each item set is created. From that again we'll remove the item set whose support is less than 2. So these are the remaining item set. From remaining item set again we'll create the triplets. So for the triplets we'll consider 1 3 2 with 1 3 2 5. Will not consider the repeated item set, so we'll only consider it one time. So 1 3 2 1 3 already 1 3 2 is already there, so 1 3 2 5. So this is the second. 1 3 1 3 5, this is the third, and 2 3 5 which is the fourth. We'll write support of each item set and discard those items so which support is less than minimum support count. So there is only one item is remaining. There is sometimes again the process is happen like again 2 item sets is there in this table. Yes, suppose there are again 1 item set is there. So for that we have to create again the pair of each items, discard those items with support is less than support count. At the end we have only a 1 frequent item set remaining. Then and only we can create the association rule from that. So for this is the final item frequent item set 2 3 5. So we'll create the association rule from that. So 2 3 implies 5, 3 5 implies 2, 2 5 implies 3. Now invert that rules and this is how association rule is created. We'll calculate support of each association rule as 2 because it is created from frequent item set. So support 2 is written as 2 of each rules. Now we'll calculate the confidence of each rules. So for that the equation is support of, if rules is A and B implies C, then support is ABC divided by support of AB. So from that equation we have calculated the support of each association rule and will convert this support into the percentage. Now in the question the minimum confidence is already given, so we'll discard those rules whose confidence is less than the minimum confidence, and the minimum confidence here is 70%. So we have removed this item set. So final item set remaining is 2 3 implies 5 and 3 5 implies 2. So these are the final association rule. So 2 3 implies 5 and 3 5 implies 2. So this is how by using the Apriori algorithm we can find the frequent item set, and from that we can generate the association rule. Thank you so much for listening. Have a great day.